Okay, this is the first of 3 videos where I will go over how to solve all of the math questions on the ACT practice test that we took at Olathe West back in October. This video is over questions 1 through 20. Okay, first question. Now notice on these questions, on the left-hand side, I am putting in the percent of people that chose each answer choice, and I'm highlighting the correct answer. So on this question number 1, we can see 53% of people got this one correct. Okay, so if we look at this, it's a probability question. We've got numbers 1 through 15 written on paper, and one piece is drawn from the jar at random. The question says, and this is a big part, what's the probability that the number drawn will be less than 9? Well, there's only 8 numbers that are less than 9. And so the answer should be 8 out of 15. Now, many people, well, that's it. So it should be 8 out of 15, less than 9. I have a feeling that the 23 people that chose letter B found they found that B is the probability that you are drawing the number 9. There's only one way out of 15, but the question says less than 9. So you'd really, really need to read these questions. Okay, question number 2 involves adding up a polynomial. When we're doing this, when we're combining things, we can only combine things that have the same exponent, right? So if I notice these two here have the same exponent. So I like writing things vertically. And when I add them up, I wind up with negative 16x to the third plus 9x squared. You want to make sure when you're adding numbers like this, when you're adding these, you do not add the exponents. The exponents stay the same. The people that accidentally chose letter K, the 17% of people, they decided to add those exponents and get a 6 instead of a 3. Remember, when you're adding, the exponents do not change. Okay, this question says when x is equal to 2, how much is this? Well, your first step should be to go ahead and change the x value to be a 2. That's what I did. And then there's 2 ways to go about this. One way is to just use pen and paper, and the innermost parenthesis would be 6. And then we would have this, 12 divided by 6 is a 2. And then of course, we know that we need to multiply first before adding. We get 16. Now, the thing is, this question could just have been done on the calculator. I could just type it in, 10 plus 3 parenthesis 12 divided by parenthesis 3 parenthesis 2. If I just type it in, we'll get the right answer. So don't be afraid to use a calculator on the ACT. You get to use it on every single math question if you want. There's no reason that this question anyone should have gotten it wrong, because you can just type it directly into your calculator. Okay. Question number 4 involves absolute value. Well, we'll do the absolute value part first, Now I went ahead and found out what 6 minus 4 was. It's a 2. And what's 3 minus 8? It's a negative 5. Now we'll take the absolute value. The absolute value of 2 is a 2. Bring down the minus sign. The absolute value of negative 5 is 5. And now we have 2 minus 5 is negative 3, letter G. I have a feeling that the 25% of people that chose letter J, they were thinking about these 2 negatives canceling. Now, again, like I said, you can use the calculator for everything. You can do it on this one too. If we press alpha y equals, I'm sorry, not alpha y equals. If we press alpha window, I can choose absolute value and just type it in, 6 minus 4. And then it says minus alpha window, absolute value, 3 minus 8. Again, we can just type it directly into the question. All right. Question number 5. What is this expression equal to? And I'm suspecting, since very few people got the answer right, that involves this multiplication that people are having a hard time with. So here's the tried and true method that will never fail you. You use the Punnett square. So we've got 4c minus 3d, that's from here. And then we have 3c plus d, and that's from here. And all we do is we multiply the pieces together. 4c times 3c is 12c to the second power. And if you weren't sure it was the second power, you can look at all the answer choices. They all are to the second power. Let's find the other boxes. This would be a minus 9cd because we're multiplying. This would be a positive 4cd. There's like an invisible 1 there. And we finish multiplying, we get minus 3d squared. So we know we start with a 12c squared, but of course all of them have that. We end in a negative 3d squared, so I think I can safely eliminate those. And then when we put together these middle pieces, I believe those add up to be, let's see, negative 5cd. So the answer should be letter C. So if you think about this setting up an elimination idea, we could have picked up these 19% of those people to not have selected those answers. Okay, question number 6. I thought this one was the most difficult one, but people did the best on this, so what do I know? It says we have 180 students in the college course. A fourth of them earned an A, a third of them earned a B, and the rest earned a C. That's not too bad. How many students earned a C? Well, a fourth earned an A, and a third earned a C. So if I add those up, we wind up with 7/12. So 7, and I can add them up using a calculator, using fractions, whatever. 7/12 earned an A or a B. Well, that would have to mean that 5/12 earned a C, right? Because that gives us a total of 12/12. So let's just do 5/12 times 180. And when we do that, we wind up with 75. And that is our answer, 75. Okay, question number 7. Reading along, we got a population expressed by this formula here, and they're telling us some things about X. X is a number of years after the beginning of the year 2000. So for example, when X is 0, we're at 2000. So when X is 0, we're at 2000. And then they say when X equals 1, we're at the year 2001. So a 1 would correspond to 2001. All right. Well, they want to know how many fish are in the pond at the beginning of the year 2006. Well, that would mean that X would have to equal 6, right? Keeping this idea together. So I just copy down the formula, change the X to a 6, and I am not going to do this by hand. I'm going to, again, use my calculator. 3 parentheses 2 raised to the 6th power. 192. That's our answer. Okay. Question number 8. Number 8, people didn't do terrible on it, but if you read it, but if you look right to the end, they say they want to know which of the following values is closest to Manish's average speed in kilometers per hour. So we should think about this. Average speed, that is the change in distance divided by the change in time. So change in distance. Well, this person was at 510 and then at 105. So if I were to subtract those, 510 minus 105, and then the time went from, they're going from 8 a.m. to 1 p.m. So that's a total of 5 hours, right? So I do this math, I wind up with, when I take this 510 minus 105 divided by 5, I wind up with 81 kilometers per hour. which is right there, letter H. Now on these questions, we should check to make sure these units agree. Like they want kilometers per hour. And this is luckily measured in kilometers. Sometimes it might have been measured in meters instead, and we would have to convert. So you just want to be aware of that. Okay, question number 9. 2 ways to do this. The first way, on the ACT, everything is drawn to scale. So what they want to figure out, how long is AC, right? Well, I know how long this side is. This side is going to be exactly, if I add up those 3 numbers, right, 21. Well, that means that this side over here definitely looks bigger than 21. So the 3% of people that said 13 were just guessing and not paying attention to this question. So what I do is I measured this, right? And you could use like your, on your test booklet, you could use your bubble sheet, whatever you want to use as a ruler. And it turns out it takes exactly 2 of them to make that distance. So the answer would be 42, right? Because it takes 2 of those. Now, the mathematical way, that's one mathematical way of doing it. Another way is using something called similar triangles. In other words, I'm going to look at this really small triangle and I'm going to compare it to this really large triangle, all right? So a side off the small triangle is 8. That would compare to 21, which is in the same location on the big triangle. And then I'm going to use 16 from the small triangle. And that would compare to this whole side, which I'm going to call X. Well, now we've got a proportion. We got to multiply it out. So we cross multiply. 8X is equal to 336 divided by 8. And we wind up with also 42. But I think to draw into scale way, way, way faster. Okay, question number 10. And you want to read carefully. They want to know what's the average number of minutes it takes her to run a mile. So this is kind of sneaky. They want to find out what is the minutes per mile. That's what they want to know. Well, if I just write out what we have, 2.5 hours divided by 15 miles, we'll notice we've got miles in the denominator, but in the numerator we have hours instead of minutes. So we need to convert that. Well, you know, every hour has 60 minutes in it, right? And then a 0.5 hour would be 30 minutes. So that'd be a total of 150 minutes. So what we should do is 150 minutes over 15 miles. And now when I divide those out, I'm going to wind up with exactly 10, which is choice G. And that is our answer that we want to know. Okay. Number 11, another probability one. And I thought this one was a bit of a stinker. They want to know how many more red marbles you need to add. So that way the probability of drawing a red marble is 3/5. Well, first off, 3 divided by 5 is 0.6, okay? So we want the probability to be 0.6. Right now, the probability of drawing a red marble, right, there's 8 of them. 8 out of 24. And when I divide those, I wind up with, well, definitely something smaller than 0.6, right? If I work it out here, let's see, 8 divided by 24. I wind up with 0.3 repeating, right? And I need to get to 0.6. So I need to get a lot of red marbles. Now, if you notice, all these answers are in numeric order. And that's true on the ACT always. So I'm going to do that to my advantage. I'm going to guess and check. I'm going to guess 20 red marbles. Now, let's say if 20 red marbles is too many, well, then I also know that these 2 numbers would also be too big. And that allows me to eliminate it down to 2 choices. So I'm going to try 20 marbles. That would mean the probability of drawing a red marble, we had 8, but we're adding 20 more marbles to it. So I got to make sure to add 20 to the total amount. When I work that out, I wind up with 0.63. Now we're trying to get to 0.6. So I know that's too big. That means these 2 are also too big. but we're really close to 0.6. So I'm betting the answer is letter B. In fact, I know it's letter B by looking at this. But if I try adding 16 instead, right? Probability of a red marble, we had 8, right, out of 24, but let's add 16 marbles to that. 16 red marbles. That turns out to be 0.6 exactly. So the answer is choice B. Okay. Oops. Question number 12. A lot of ways to do this one. I like using graphing because these numbers are not very big. They are giving us 2 points, 2, 1, and so 2, 1 is the midpoint, and they're giving us 1 point, and we have to find the other. So what I've done is I've plotted out the midpoint right here, and this is point C. Well, we have to figure out where point D is going to be. Well, if I just even eyeball this, I could definitely see that point D is going to be 2 negative numbers, right? And that allows me to get rid of just those 2 choices right away, or those 3 rather. So that's not bad. But let's keep working this out. Here's the quick way to do it. We're going to go down 1, 2, 3, 4, 5, 6. We're going to go down 7, right? So we're moving down, let's call it a 7. And then we are moving over 1, 2, 3, 4. So let's do the same thing. Let's go down 7, 1, 2, 3, 4, 5, 6, 7, and over 4, 1, 2, 3, 4. That's our new location. And that location is at -2, -6. There's lots of other ways to get this, but I think this is the fastest way to go about it, okay? So -2, -6. There it is, choice G. Yeah, there are some formulas you can do and such, but that's what I would do. Graphing is really quick. Okay, number 14. This person works, he works a job. He gets paid 15 bucks an hour for regular time. And then he gets 1.5 times for working overtime. So if he works over 40 hours, he gets 1.5 times. Now it says this person worked 46 hours and got $117. How much of his pay remains? Okay. Well, on this one, what we want to do is we're going to go ahead and take, now again, this person earns $15 per hour, right? So first off, 40 hours times 15 bucks, right? That's straight pay. Now let's add the overtime. He worked 46 hours. That means there's 6 hours of overtime. And during overtime, it says he gets 1.5 times as much. So 1.5. Now, when I work all that on my calculator, I get $735. Now, notice I do see choice E, but the question says after deductions were taken out. So let's go ahead and subtract the deductions, 117, and we wind up with $618, which is choice D. So this was a little bit of reading on that. Those 8% of people, that's what happened to you. Be careful. Okay, number 14. 14 says, how much money would Janelle have saved if she had instead purchased 7 bags in one trip on Monday? So 7 bags. Well, we got to read here because the price per bag is different depending on how many you buy. So it looks like she did 2 trips. She bought 3 bags on Monday and 4 bags on Wednesday. So 3 bags on Monday. So you bought 3 bags. That means the total was $3 per bag. And then she bought 4 bags on Wednesday. Well, when you buy 4 bags, they only charge you $2.80. So if I use my calculator on this, I wind up with $20.20. Now the question says, how much money would she have saved if she had bought all 7 in one trip? Well, that's right here, right? So 7 times 260. that winds up with $18.20. And if I subtract those, I get $2. And that's how much this person would have saved. It's kind of like the other one with the regular pay as well. Okay, question number 15. What is 3% of this in scientific notation? Well, first off, the word of we know means to multiply. So we should have 0.03, right, times 4.14 times 10 to the fourth. Now, what I'm going to do is I'm going to use my calculator and type that in. 0.03 times 4.14 times 10 to the fourth power. Notice I'm not going to bother with the scientific notation buttons. I'm just going to type it in exactly how it appears. And we wind up with 1242, which is choice A. Purely just type it into your calculator, come up with a result. Okay, question number 16, we're going to solve this. Well, first off, I think we should distribute everything. So that would be negative 12x plus 15 would have to equal 2 minus 10x. That's the first bit. And you notice you got x's on both sides. So that makes it a little confusing. We probably want to get rid of one of those. So maybe I get rid of this one by adding it to both sides. That way they're opposites. And now we have just a 2 over here. And then we have negative 2x plus 15. Well, let's go ahead and subtract 15s. That gives me negative 2x is equal to negative 13. And then let's divide everything by negative 2. And remember, the negative signs cancel out. So we have 13 over 2. And if I look at that, there's letter K, 13 over 2. Okay, 17. They want us to find the sine of angle A. So this is the one where you need to remember the acronym. So, ka, to. Now, S stands for sine, C stands for cosine, T stands for tangent. They're asking for sine. So I need to pay attention here. Remember, the sine of an angle is equal to O over H. So it's opposite over the hypotenuse. Okay, that's what that acronym tells us to remember. And if I look at this, we're dealing with angle A. Opposite is 7. And the hypotenuse is 9, because 9 is opposite the right angle. So 7 over 9, choice D. So this came down to knowing your acronym SOHCAHTOA. There's about 7, 8 questions to deal with trig on this, so be aware. Okay, 18. A lot of ways to do this one. Let me do the mathematical way, and then I'll just show your calculator. What you should probably do is, I notice that there's a 3 in the denominator there. So I'm going to rewrite this to third powers of something to a third power. In other words, I believe 3 to the third power is 27, and 3 to the fourth power is 64. Now, a power to a power means we multiply, right? So what I could do is this way. Now, there's a much faster way, but now if I multiply those, I believe these 3's cancel out. And so we're left with 3 to the negative 2. Oh, whoops, sorry about that. I had a small typo here. This is all 3 to the, whoops, doggone this stuff. 4 to the third is equal to 64. So this would be 3 times that. And again, these 3's cancel out. So we're left with 3 to the negative 2 on the top, and then we're left with 4. Boy, I'm just really struggling here. We are left with yeah, here we go. Those 3's cancel out, and we're left with 4 to the negative 2 power. which if I make them all positive, it means they switch. So it becomes 4 to the second on the top and 3 to the second on the bottom, which is 16 over 9, which is letter J, right? That's the correct answer. Now, the thing is, could just type all this into the calculator, right? Parenthesis alpha y equals fraction 27 over 64, close a parenthesis, and let's raise it to the, let's see, fraction -2 over 3, 16/9. I think that's a little bit faster than what I was doing. Okay, 2 more problems. Number 19. And this one, it was a bit of a doozy here. Not very many people got it right. Just over guessing, actually. It helps to draw a picture. So the person begins at their back door and walks 8 yards east and 6 yards north. So I'm going to draw a picture for that. They're starting here, and we got to remember, you know, north, south, east, west. They walked 8 yards east and 6 yards north. Then they walked 5 yards north. From there, let me read here. So 8 yards, and then they walked 12 yards east and 5 yards north. So then they walked 12 yards east and 5 yards north. Now the question says, how many yards less than would he walk if he could walk directly to the back door to the bark dog? Like if I were to add these up, right? 8 plus 6 plus 12 plus 15, we get a total of 31, right? And notice that's where E is. And maybe that's what these people were thinking of. The question says, if this person were to travel a straight line, how much faster is that? Well, I do see a right triangle here if I draw it in. And this right triangle has a height of 11, right? This distance is 11. And this distance here is equal to 20. So what I could do is Pythagorean theorem, right? A squared plus B squared is equal to C squared. In other words, 11 squared plus 20 squared is equal to C squared. Well, if I do that, you know, 11 squared plus 20 squared, we wind up with 521. So 521 is equal to C squared, or C is equal to the square root of 521. So if I do that, square root of 521, all right, 22.8. So I'm going to subtract the 22.8 because that's the shorter distance. This comes out to be 8.2. That's how much would be saved. So which one would it be?
Any junior or senior interested in joining Rho Kappa, please make sure your applications are returned to your community
Last
office
one.
by this Friday. Interviews will begin next week. See Mrs. Ruport or Mr. Berggren if you have any questions. The Dungeons and Dragons Club will have an informational meeting tomorrow during the first part of seminar. If you are interested in attending, you must have a seminar pass from Mr. Flynn. Sophomore and junior students wanting to attend the OATC field trip on Wednesday need to turn in their permission forms to the junior office by tomorrow. Students without a permission form turned in will not be able to attend. Blank permission forms can be picked up in the sophomore or junior office. Thanks and have a great day.
Okay, so what I'm doing is I'm just plugging in the numbers where they go. We're told Z is equal to 2. So I'm plugging that in for the Z value. And then we're told values for these as well. So I'm going to plug them in. So X minus 78 over 6. And all we have to do is figure out what X is. So I think we would cross multiply first, right? 12 equals X minus 78. And if we add 78 to both sides, I believe we get an answer of 90. And that's it. Okay, this was the first 20. I'll make some more with the next 20 and the next 20 after that.